File system is the most important part of the operating system. In the sense, without file system, it will be very difficult for us to access the information in the computer. So I'll just take an example. See, let us say you have a video, right? And whenever you want to, save this video on the computer, you have this hard disk. Okay, first of all, why do you have to save this information? Is any information in general is because your main memory is volatile, which means if you switch off your computer, you know that main memory doesn't last longer. So that is why we try to save everything on the hard disk, and later when we need them, we have to fetch them. And the way hard disk is organized is very much different from the way you think the file is organized. In the sense, let us say take a video. If it is 4 MB, 4 MB video has to be organized across the disk, hard disk. But then the hard disk will not be having a contiguous size of 4 MB available for you. Therefore, you have to divide the information which you want to store into various parts, which is called as blocks, and then map these logical blocks onto the physical blocks, right? What are physical blocks? I'll talk about it later. The hard disk is actually partitioned into something called as blocks, right? Which means like this. If you have a hard disk, even though I'm going to talk about it later, I'll just give you a brief overview, right? Hard disk or any storage device will have small units or chunks of memory which is going to be accessed all at once, either to read it or to write it. So whenever you want to access the smallest information which is present in the hard disk, you are supposed to take the block, right? And now let us say your file is in such a way that it needs 10 blocks to save that file. Let us say a video file. Now if you try to find all the 10 blocks which are contiguous, you may not be able to find it. Or even if you are able to find it, later when you want to fetch it and do it on your own, it will be tedious without the support of operating system. Therefore, operating system just abstracts it out, which means operating system will just leave out the details about how your hard disk is actually structured. It will provide an abstract data structure which is called as a file. So using a file, what we can do is we can provide to the operating system the logical file, and now the logical file will be taken by the operating system and it will store it physically on the hard disk. This entire thing is done by the file system. The entire code which is required to do this process, which is used to create a file, store the file, fetch the file, everything. I'll tell you what we can do on the files, but the entire code which is required is going to be present in the operating system, and it is the most important thing. And what I mean to say is, whatever you try to save on the computer is going to be saved as a file, right? To operating system, everything is a file. Either it is a video, or it is executable file, or it is a text file, or it is even some collection of records of the database. So what we generally do is we collect all the what can I say, logically related information into a file. So if you want to see how the concept has arrived, we have some information, and then we collect the information which is logically related, like let us say maybe all the employee records of a company. These is all, they are all related, right? We collect all the related information and we put them into files, right? And then these files are going to be stored in our computer, and if you look at the number of files in your computer, they are going to be very large number of files are going to be there, huge number of files are going to be there. And now in order to manage these many files, it is sometimes going to be difficult. Therefore, we even group the collection of files which are logically related into something called as directory, okay? And then we even group the directories which are logically related into something called as file system. Therefore, file system can be viewed as the software which will manage and create all the directories, which in turn will contain all the files, which in turn will contain the information, right? This is the way it is going to be, okay? And now what will our file system of the operating system perform is, it will perform various operations, and it will give you the code, the executable code, in order to perform various actions. We shall see all of them. Okay, so for now understand that. Later we shall again see in the hard disk about how the file is actually stored on the hard disk, but now let's look at only the logical view of the file part. Okay, so now file is a abstract data structure which is going to have some attributes like in the data structure. Okay, so now let's see the file attributes. So first thing is, every file is supposed to have a name. You know this, we definitely name every file, otherwise it will be difficult for us to take it back, right, when required. So every file is going to have a name, right? And what type of name it is? Generally human readable. Along with the name, it is not compulsory, some of the systems will use it. You are supposed to provide an extension which will help the operating system in choosing the application in order to use a file. For example, if you see .exe, then when you click on the file, operating system will try to execute the file because it is executable. .exe means executable. If you save the file as doc, right, maybe in Microsoft, then it is going to open the Office, MS Office, in order to open the doc, right? So these extensions are going to be kind of hint provided to the operating system, and it is not mandatory. If you provide it, it is good. Okay, in some of the systems it is mandatory, and recently all the operating systems made it optional. We need not provide it with any extension. It is automatically going to add the extension in case if it finds out the type. Otherwise it is going to leave it as it is. Later when you try to open it, you are supposed to even specify what application you want to open that file with. Okay, and now maybe if it is a video, if you save it as .mov, maybe a video player will open it if you click on that, right? So these are all hints, right? And the next one is type. So the type of the file specifies what is the information which is present inside the file. There are various types of information, types of files you can save on a computer, like executable file, video file, audio file, and maybe text file, or a collection of records, or a sequence of bytes. So whatever, you are going to have the type of the file also. So this is also going to be an attribute. So this particular type of the field, generally some operating systems are going to provide you when you try to save a file. It will even ask you what is the type of it, as if you provide it, it will be better for it to search and open the applications which are related to that when you try to open the file. And the next one is location. Sometimes what happens is, a computer might have more than one storage device connected to that. Maybe you might have external hard disk, and maybe you might have internal hard disk in your computer, and then some of the files might be on the internal hard disk, and some of them might be on the external hard disk. Therefore this location gives the hint to the operating system about where this particular file is located. So it is nothing but a kind of pointer which points to the physical location in which this file is present, right? And the size says what is the total size of the this file in bytes. So why is size useful is, okay, later we shall see it. Okay, I'll tell you, we shall do some problems on it, like if you have a file of size so and so, and the block size of the hard disk is so and so, then how many blocks is it going to take? Then what is internal fragmentation? We shall see that questions later. So size is going to be an important attribute to a file. And the next one is protection. So you are not, sometimes what happens is, you don't want anyone or everyone to run all the files on your computer. You want to give some access, some types of access to some types of users. Maybe to ordinary users who are not admins, you don't want them to run a program which is used to remove every directory, remove a file from a directory, right? So like that, you can specify that these are the class of users or the group of users who can perform these actions on this file. Sometimes you can say that some people can only read a file but they cannot delete it. Some people can only write a file, they cannot execute it. So likewise, protection is used to just save the files which are to be saved or which should not be given access to everyone, right? And the next one is time and date. So this indicates what is the time and what is the date you have created a file. It will be useful in some cases. Let us say you have a source file and a compiled version of it. You have a source file and a compiled version of the file .exe. Okay, and now you can develop an application in such a way that whenever someone clicks on the .exe, your application should search the source file which is related to that, and in case if the source file is modified after this exe is created, that executable file is created, you can ask your you can write the application in such a way that it should compile the source file again into the new exe file and replace the new exe file old exe file with the new exe file and then run it. So in this case, maybe having this time and date of creation and time and date of lost modified may be useful. For example, let us say here it is .exe file is lost modified or created on May 5th, right? And then source is modified, let us say May 10th, and today is, let us assume that it is May 15th, and if you are trying to execute this file, then it is better that you check if the source file is modified. Yes, the source file is modified. It has executable file is created on May 5th, and then the source file is modified on May 10th, and now you are trying to execute it. Therefore, it is better that you compile it again and then get the latest copy of the .exe file and then execute it, right? So in such cases, this attribute will be useful. Okay, and next, apart from these attributes, see what is the need of this attribute is, I told you that a file is nothing but an abstract data type, and every data type is going to have some properties. These properties are nothing but the attributes. Now these attributes are just like the metadata about the file. So once you read this entire information, you got everything that is required about the file. It will be easy for you to open the file, read the file, write the file, whatever you want to do. This information is going to be useful first, right? And then there are some operations which you can do on the file. What are the general operations that you do? You must be aware of it, right? You must be knowing most of the operations. I'll tell you what they are. So one is creating. So file operations are nothing but the most important operation is we keep on creating the files, isn't it? So we have to create it, and then after creating, we generally write. So whenever we create, what happens is some space will be allocated for the file on the hard disk, and then when you try to write some information, then we are going to add some bytes to that space, right? Now here one thing should be important. In order to see, your file will be growing, right? And let us say this entire space is allocated for your file, and maybe you have written it till here, and next time again when you try to write onto the file, you should again start writing from this point where you have previously left writing, isn't it? Therefore, in order to understand where to start writing, if the file has already been created and if something has already been written, we are going to have a pointer. Let us say write pointer. So operating system is going to maintain a pointer with every file which is going to indicate till what part it has been written, so that you can continue writing from there on, right? And similarly, when you are reading, you read a file sequentially in most of the cases, right? Other than these database applications, generally we do sequential writing. So whenever you are reading, you are going to read sequentially. Therefore, you should even remember what is the last byte that has been read, so that you can read the next byte. Therefore, it is often useful to save a pointer which is called as read pointer, right? So most of the operating systems, in order to avoid using these two pointers, I hope that you understood why these two pointers are required, because a file is going to be a huge space, and now you can either read or write anywhere. And in order to keep track of where you have been writing and where you have been reading from, it is always better that you mark some pointers, right? So that is why we are going to use pointers. Now read pointer and write pointer are two variables which have to be maintained by the operating system, because generally what you do is, whenever you want to read or write something from the operating system, something from a file, you ask the operating system. Therefore, it is the responsibility of the operating system to save it, right? To save the pointers. So what operating system is, many operating systems are trying to do is, instead of using two pointers, this read and write, they are generally using a pointer, because it is based on the assumption that we either you open a file to read or to write, and we don't generally do both of it simultaneously. Therefore one pointer is going to act as either read pointer or write pointer depending on how you opened it. If you are opening it for read, then it is going to act as read pointer. If you are going to open it as write, then it is going to act as write pointer. Therefore having that marking, maybe you can think of it like a bookmark, right? When you are reading a book, if you close it later, if you want to open it and read it, it is better that you place a bookmark in that, isn't it? So this is the kind of pointer, is kind of bookmark, and it is going to be useful. I'll tell you later where it is going to be useful. And the next thing is repositioning. Repositioning is, if your read pointer or write pointer is somewhere here, and maybe if you want to skip some part and go to the next part, right, then you are going to use repositioning. There are various commands like seek. Not important, commands are not important, we should not get into that. Let's get only these terms. Okay, so repositioning means just moving the pointers here and there, wherever you want to move them, sometimes if you want to skip it, right? And next one is deleting. So deleting is nothing but you want to delete this space allocated to the file, as well as the information about the file itself, which means even this entire information has to be deleted. It is not just the space allocated to the file. See, as I said, file means it is not actually one thing, it is complex thing, it is a data structure, right? It is actually the space allocated to the file. Along with that, even the metadata means the attributes, right? And deleting a file is deleting the space, freeing up the space allocated to that and giving it to some other uses, the space. Along with that, deleting the attributes also, right? And now truncating the file. So truncating means we would like to free up the space which is given to the file, but then keep the attributes. It is just like this. We don't want the data in the file. We want to again redo the complete file. We want to replace the complete information with some other information. Then what we do is, first you free up the space, and then again you create the file, but then you need not create the complete file. The attributes are going to be there, so only some few things are going to be changed in the attribute, like this size. So you can think of it like this. How can I explain this truncating is, I'm not getting any real-time application. So see, what I'm trying to say is, you are just going to delete the space allocated. The information, everything will be gone, but the name and everything will be there. All the attributes will be there. Later you can add the information freshly, right? Truncating means just the space which is allocated to that will be freed up and everything will be there. The attributes will still be there. Okay, fine.